Hello, everyone. I decided to do record videos because I wanted to. Okay, let's get in. So, introduction to statistics. We don't want to look at these definitions, these are not needed. So, descriptive statistics are procedures used to organize and summarize a set of data to make it easily understandable. So, it tells you what you have right now instead of generalizing what you have. That's what inferential statistics is for. You get a bunch of data and then you generalize it to achieve stuff, I guess, to prove a point. Procedures used to draw conclusions and make generalizations that go beyond the collected sample data. Okay, we have three main terminology. The first one is variable, which just means something, anything that can take on different values. Different variable. That's why. Value is a possible number or category that a variable can take. So the reason it says category is, for example, you have a nominal variable that would mean that your variable can be, female or male, for example. And the score is, the specific individual's value in a given variable. So the score is a bit different because there's not really much of a difference between value and variable. But there's one minute difference. For example, let's say you have a variable called stress level. And for example, you have a test question that says, are you low cortisol? And then the person responds with a 5, for example. That's their value or the score. But when you're actually taking that test or when you're actually computing that test, you may give it -5 because that would be indicative that they are not that stressed about stuff. So the score can differ like that. A value doesn't necessarily have to have the same score. A value of 5 might be -5 in your computations. Now we have 4 different levels of measurement. The first one, as I said, is nominal, which is just categorical. What are these? Country, nationality, medical diagnosis, etc. The second one is rank order. What are these? These represent ranks, what is it? First place, second place, etc. The third one is within the quantitative section, and these are both numeric values, whilst rank order is ordinal. So the first one we have is equal interval, which just means 0 to 10, for example, 1, 2, 3, 4, 5, rated on a scale of 7. Whereas ratio has a point of absolute 0. So you can make twice as much comparisons. What does this mean? For example, when you say a stress level between 0 and 10, that 0 doesn't necessarily mean that you have 0 stress. It just means that you have a perceived 0 stress. But for example, when you say the amount of brothers or sisters that you can have 0 sisters or 0 brothers. There's no literally limit to that. So that's a difference between them. If there is an absolute 0 point, then that's a ratio scale. And we have 2 additional classifications for these variables, mostly the equal interval and the ratio scale. So discrete is basically an integer. So a discrete variable, let me go down. A discrete variable goes 1, 2, 3, 4, 5, 6. Okay. But a continuous variable, since it's a float, it has infinity. between 1 and 2 when you look at it on a, what do you call it, the ruler thing. So there is 1.00000001, there is 1.00000002 between these two values, you know? So that's what we call a continuous variable. Let's look at frequency tables. How do you create a frequency table? To create one, you list each possible value from lowest to highest. The reason we do this is to get rid of confusion and to, what do you call it? To make it easier for us to actually manage. And when we want to get the median of that table, which is the value right in the middle, it will be easier for us if we just do this right out of the gate. So you get a bunch of values. Let me see if I can find this example of creating the frequency table. So you count the amount of times each value appears. You see 5, 7, 4, 5, 6, 5, 4. You take these and then you put them into a table. How you calculate their percentages is easy as well. You take the frequency and divide it by the total number of scores, and then you multiply it by 100. I will probably forget this, but it's quite simple. It's basic maths. It's just that I'm very stupid at maths. What happens when your data has so many data points that it would be impossible to really look at them each on their own? So, for example, you have data ranging from 1 to 1 million. What are you going to do? You're going to get that data, you're going to split it. You're going to say between 0 and 300,000, for example, because it's, I said one more zero, yeah. Let's say we create different groups, 0 and 300,000, for example. And then we have another group between 300,000 and 600,000. And then we have another one that is just 600,000 to, I don't know, 1 million. So instead of dealing with 1 million separate values, we only have to deal with 1, 2, 3, literally 3 variables now, or 3 scores. So that's what you do. By talking about grouping the frequencies of adjacent values, it just means that. So 5, 6, 7, you group these into the group of 5 to 7, you know, because they're adjacent. Now, the difference between histograms and bar graphs is fundamentally bar graphs are used for nominal variables, whereas histograms are used for numeric variables. And now we get a little bit of more confusing stuff. Now we come to the shape of distributions. Unimodal means you have a single curve, just like this. I guess we have single curves anyway, but in a unimodal model, it strongly resembles the bell curve or the normal distribution curve that we have. In a bimodal distribution, you have 2 peaks. What does this mean? This means you have 2 separate groups within your data. So 2 separate types of groups have taken your tests or whatever you're trying to achieve, and they've both taken it. Multimodal is... bimodal is a part of multimodal, and multimodal just means it has more than 2 peaks. Rectangular means all values have approximately the same frequency. So what would happen if you just rolled the dice, I don't know, 200 times, is you would get a rectangular distribution. because they would all end up averaging themselves out. Symmetry means the left and the right sides are mirror images. This is what we want. If you don't have symmetry in your data, by the way, this indicates the mean, then your data is skewed. We have positive skew and a negative skew. How you find out which one it is depends entirely on the tail. You can see the tail here. This is what we call a tail. This is a peak, and these are the tails. If the scores pile up at the low end, this is the low end because we're going from left to right, then you have a positive skew. Because the data that are present at the positive side going to the right are skewing your data from becoming a unimodal normal distribution. Instead of it going, it's going. I don't know if it's understandable, but so you look at the tail, and if it points to the right side, then that means that it's positive skew or right-sided skew. If it points to the left side, then it's a negative skew. Because the scores at the negative side are skewing your data. So it's not going, it's going, I don't know if it's understandable. Okay. Kurtosis, I got no idea what this is, but it shows you how fat your tails are. So this is a mesokurtic distribution in the bell curve. Fewer scores in the tails and less extreme values. You see, it's nice, uniform. If it's leptokurtic or peaked, it goes more, I guess, sharp at the top, but it gets fatter once you go down. This graphic is not really indicative of how it actually looks. I believe I had a better one. I cannot find it though. Oh my god. Okay. Anyway. It means there are more scores in the tail and there are more extreme values. It's more peaked because it goes some like this, you know? The shoulders are less wide. When it's flat, there is fewer scores in the tails, and we call that flat distribution. I really don't understand kurtosis. If you do, explain to me. Let's check the actual definition so I don't give any wrong information. Well, a normal curve is bell-shaped. Kurtosis describe how much distribution deviates from the normal curve regarding how peaked or flat the middle is. A distribution that is more peaked than normal has more scores in its tails. This is what we're looking at. The peakedness is not really important. It's just a side effect of the fact that there are more scores in the tails. Well, a flatter distribution has fewer scores in the tails. Because there are fewer scores in the tails, it's more rounded out, I guess. The tails are not that important, I guess. I don't really understand. The thing you need to know is if there are more scores in the tails, it gets more peaked. If there are fewer scores in the tails, it gets flatter. Oh, and now researchers choose a measure. Final articles tend to feature bar graphs and more complex tables. That's all you need to know.